Hey everybody, Alan Noon here, and we are picking back up with our paper 2D project. So we started this many moons ago, almost probably a year, quite honestly. And the last session was session number 3, and that was a full 4 major point releases ago. So coming back to this project, I had to go back through and kind of clean a few things up. And I went back and rewatched all of the streams and took a look at the question about ladders that came up. We never really finished that, so I went through and kind of made a nice clean ladder. So I'll walk you through that. Also, back in the day, we were doing the damage system where we were flickering the character. I didn't really like the way that turned out, and so we're going to do that slightly differently. Again, I'm going to walk you through that. In cleaning this project up, I went and did a whole bunch of work, and it's actually too much to kind of fit in the stream today. So again, we'll walk through a couple of things, and then we'll talk about the weapon system. So we'll build out a quick system using data tables, and we'll actually build that one live. So we'll see how that goes. But you can see that our scene looks a little bit different than when we left it. I added a few more blocks and made it a little more colorful and interesting. But if we go ahead and play, so we can run around, we're stepping up on these blocks here, we have our shooting happening, and I'm kind of doing a very old school thing here where once I start shooting, I'm actually locking the character into place, and we have a slight delay before we start running again. And then, yeah, let's take a look at our ladders. So we can pass by our ladders, and when we're in front of them, we push up to make it to the top, and then we can climb back down. So a couple of different components to this. There's the actual ladder itself, and then there's the reaction of the paper 2D character. So both of them have to communicate with each other to get this all going. So I guess we'll start with that. Oh, real quick, let's go back and we'll take a look at our damage. So yeah, so now we're doing a couple of different things here. We're flickering our character and we're also changing the color. Let's take a look at our ladders first. Okay, so first things first, I'm going to select our ladder, and you see I have this little widget up on the top here. If I go ahead and start dragging that around, you can see that we are actually dynamically changing the size of the ladder. So let's go ahead and take a look at that. I'm going to right click and just edit this blueprint, and we'll go to our construction script. Okay, so right out of the gate, we're going into a sequence. Love my sequence nodes. And we have 2 vectors. So we have one for the top of the ladder and one for the bottom of the ladder. So we look over here on the side, bottom is private, but the top one is actually editable. And if I select that and go to its details panel, you see this little checkbox here, show 3D widget? If we turn that on, that's what gives us this nice little diamond widget at the top that we can dynamically change. So we're getting the position of that and subtracting. And then we've got a variable here for the rung offset. So this is basically like a pixel offset. The size of the actual sprite that we're using is this one back here. Let's go take a look at our sprites. Those are environment sprites, and it's actually sprite 15. So if we double click and open this up, we can get a feel for what this looks like. 10 pixels tall. I'm going to jump back in here. And so we want this pixel perfect. So I'm going to go ahead and truncate this to turn it into an integer. And so basically, we're getting the distance, dividing by the rung offset, and then that's going to give us how many new sprite components we're actually going to spawn. So you can see that here. We're adding a paper sprite component. And yeah, using the offset here. And then we're actually setting the sprite. We have a variable here for the ladder sprite. And then we are going to turn collision off of that sprite. So that's that whole piece of the puzzle right here that's going on. Getting those locations, subtracting them out, figuring out how tall the sprite is, and then spawning the proper amount. And if we take a look over here on our rung offset, we can start, let's back up. We can go ahead and start, really packing these together or spacing them apart, depending on how large or small our character is. And again, if we want them pixel perfect, we can just, I've got it set to a float at the moment, but we could just enter an integer value. Okay, so then what else are we doing? So after we do all that, we come out of the loop, we're completed, And we've got another component here, the box component. Let's take a look. There's not really much to see in the viewport here. Everything's kind of collapsed down. This is all created dynamically at construction time. So the reason we have a box component is you can see it kind of outlined here. The character needs to know that he's in front or in range of the ladder so that we can set him to a state that allows him to climb things. And so we're just using a simple box collider. And we've got that set to overlap. There we go, overlap all dynamic. And we're setting the relative scale, and how we're doing that is, since we know how tall our ladder is, we're just getting that size and then positioning this box halfway up and then scaling it. You can see here we're setting the location, we're setting the scale, so that is giving us our actual box here. If we look in the perspective view, slide over and take a look. I've set it to visible just so we can see it. I've actually given it some depth so that we can ensure that the character sprite overlaps it. Right. Okay, so that's the construction of the actual ladder itself. And in the event graph, so what do we have? On component, begin overlap. This is that box collider again. We're going to cast to our paper sprite character. And if he's overlapped it, we're going to set him to the climbable state. He can climb. And then when we end, we're going to basically do the opposite. We're going to turn off climbing. And then we've got a custom event here. This handles his exit state from the climbable state. And so let's go ahead and double click this. We're going to jump over. What I just did there is I jumped from the ladder over to our BP dude. So we can take a look at this actual exit event here. So we're going to set him back to standing and update his animation. So whether he exits on the ground or in the air, the update animation system will tell him to go into the standing animation. Again, if he's falling, the character movement component's going to understand that and put him into his falling animation, his jump animation. And then we're setting our movement mode back to walking. So this is also a very important part of this. All right, so we have an axis event for moving up. So the first thing we do when we've overlapped it, we've been set to climb. So if that's true, we're going to assume that is. And then this is just a simple filter. Because we're using an axis event, there's a constant stream of data coming out of the input hardware. And so I've just done this for simple filtering. Basically, this acts as a dead zone. We want to make sure that the player is actually engaging climbing up in order for this to trigger. So we're going to go ahead, and if he's climbing, we're going to set him to climbing so that we can update his animation, and that'll play the animation there. And let's go ahead and we'll jump up to that part. Here's our animation. See, we have a state in our character movement state, or our character animation states. So we're getting our sprite, we're setting the flipbook to his climb, you can read there. And then we're also getting his velocity. And again, we're just filtering this to make sure that he is actually moving. And actually, hold on, let's back up and take a look at that again. So what we're actually taking a look for here is whether we're climbing upwards or downwards, okay? So we say if it's positive, if he's not climbing at all, then we're going to set the play rate to 0. So as the character climbs up, we'll take a look at this. We're passing in front, we're setting to the climbable state. Now I'm going to push up, and I play my climb animation, and if I stop, if my velocity is 0, I'm just going to set my flipbook animation to a playback rate of 0. So that's how he knows whether or not to keep playing or not. All right, and then, yeah, so we could actually change the play rate on the flipbook itself, but I just, I set the play rate here so that I could tune it out and tweak it as much as I would like. Okay, so that's the climbing animation portion. Let's go back to our climbing system. So that was updating animation. All right, so this is one important piece of the puzzle here. So we're getting the character movement component and we're setting the movement mode to flying. So normal movement mode is actually walking. I experimented with disabling gravity, setting gravity scale to 0, but really what you want to do is I found that you want to set him to flying so that gravity isn't affecting him at all. So once he climbs up that ladder, he's technically in the flying mode, okay? And we're just setting that climbing animation. And then we're adding movement input from, of course, all the way back here from our axis. Okay, and then I did not want our character to jump on the ladder, so I'm just setting can jump to false. We could potentially have a system where you could jump up the ladder to climb it more quickly, but let's keep it simple. Okay, so we went over climbing end. Now, there's another piece to this ladder here. You notice that when we climb to the very top, if you recall, our sprites don't actually have collision on them. So initially what was happening, when I got to the top, my character would fall all the way back down to the bottom. I needed something for him to stand on. So if we go and look at our ladder, let's take a look at our viewport, and you see I have a static mesh here, and you can see it's that piece. We got a little bit of camera clipping going on. Let's see if we can see that a little bit. Okay, so there's probably a better way, a smarter way to do this. A programmer would probably handle this differently. They'd come up with a new sort of platform type that allows you to pass through the bottom and stand on the top. But being a tech artist, I went the art route. And what I'm doing here is I'm taking advantage of the fact that this static mesh is just a simple plane. There's no actual geometry, on the back face over there. So by taking this static mesh, pardon me, let's go ahead and take a look at this static mesh. Doesn't really matter that we see it or not. But I'm going to set collision complexity to use complex collision as simple. So what that's doing is it's actually looking at the normals of the geometry and using that as the collision. Now, if we would have gone and tried to add, box collision here, that's actually going to be collision in the 6 directions. And so our character would not have been able to pass through. But again, since we're using simple or complex as simple, we're going to pass through the side of the geometry that doesn't have any normals, and then when we get to the top, we'll stand on top of it. All right, so that's kind of how I figured out to do that. Now, going the opposite direction, standing on top of the ladder and going down, all of a sudden became an issue. So we had to figure out a way to detect the ladder once we were standing on top of it. So what I'm doing here is I'm doing a line trace, and I'm going to go ahead and turn this on. I'm going to go ahead and say one frame here. So basically, I'm casting a ray from the character capsule downwards or upwards, whichever direction we're going, and then I'm detecting what we've hit. So we'll take a look at this before we walk through it. So you can see there, as I push up, we can see our little ray, and as I push down, you can see it there. It turns green. This might be difficult to see at this resolution, but it's detecting the hit on the ground there. Now, as I go up the ladder, I get to the top, and once I push down, you can see our ray going on. Let's take a look at what we're doing there. So here's our ray. This is where we're casting from. This is how far down we're going. So we cast to the ladder to make sure we're hitting it. And if it's true, we've got this function called allow down, which we'll take a look at in a second. But we're going to get that static mesh component on the ladder, and we're going to set the collision to no collision. So as we're at the top, we push down, detect we're on a ladder, we're turning that collision off, which allows us to pass back down. Let's take a look at allow down. And basically all allow down does is the same thing as component begin overlap. So we casted the character and we're saying that he can go into climbing mode so that we can then trigger all of his animations. All right, so yes, hopefully that was fairly simple to follow. Not as much fun as building it live, but we do have a lot of stuff to cover. So now we can start placing some of these things. Let's go ahead and find our blueprints. And we'll drop another ladder into the scene. What it looks like. So you can see my snap is set to 1, so we should be snapping pixel perfect. I'm going to select that widget and start dragging out. Oh, why are you not drawing? Grab the top. That says top. Odd. bet I have not set the sprite on that. That's probably what it is. But anyway, you can see that it's functional. I'm just going to grab this one since it works. All right, cool. All right, so here we have our ladder system that we should be able to use and extend to create all sorts of other climbable objects. All right, so let's talk about the damage. So we can see the flickering. Yeah, so now originally what I was doing in one of the previous live streams was getting the visibility setting of the paper sprite and animating that on and off via a timer. I've had mixed success with this. I wasn't super happy with how that came out. So I went ahead and this time I've handled it through the materials. So let's take a look at our guy here. I'm going to take a look at our sprite. And we'll take a look at our construction script to begin with. So we're getting a reference to our sprite and we're creating a dynamic material instance based off of this player sprite, this new player sprite material instance that we've created. And then we're setting that as a sprite material so that we have a reference to it. Setting that to a variable. So let's have a look. First, let's have a look at our original sprite material. Let's see what that looks like. We'll go to just like a generic one of our base sprites here. I'm just going to open this up. Okay, so he's using this mask sprite. So let's find that in the content browser. And that is actually a material instance. So we're going to go and find the parent. We want this one. Find that in the content browser. All right, so you can see down here, I'm actually in the Paper 2D content. This is one of the engine content folders. If I double click this, this is what our original default sprite material looks like. Let's pull this up to the top. Pretty simple. We have our source texture, we have vertex color so that we can adjust that, and we're just multiplying those together to get emissive because it's unlit, and also setting our opacity. So what I did was I took this material, close some of these things down. Second. I grabbed this material and I just dragged it into our project materials folder and I made a copy. And I started modifying it and I came up with our new sprite material. So this looks exactly the same as what we were just checking out in the default, standard Paper 2D material. But we've added a couple of things. And two components to this. So we have the actual color that the player changes once he's been hit, and then we have the actual flickering, the visibility. So looking up here at the color, all we're doing is taking our texture, and then we're multiplying that by this color here if we're hit or not. So we have a lerp. So I'm using the value of 1. That's the equivalent to white. We could set this to another color if we wanted to. And then we also have, we're driving the blend between those with just a simple scalar parameter. And again, to create one of those, we're just going to hold down 1, create a scalar, and then right click and convert to parameter. And then I've just named it isHit. Okay. So when we've detected the collision with the spike, we just change this value. And that is going to change the color of the actual sprite. So we can show that in our blue. Oh, let's go up here to our event graph, and way at the top, this big red section. This is our damage system that we had created. This should all be the same as previously. We're just detecting the hit, stopping the movement. This is for our animation, adding a force to kick us back. Okay, so this is new. So we have a reference to our sprite material that we created during the construction script. We're getting that parameter value of isHit and we're setting it to 1. So it's going to use that second channel here in the lerp. So that's how we're changing our color. And we update our animation. We're subtracting all of our health. All of this is the same from previous live streams. Basically, we're just detecting whether or not the health has gone to 0. If that's true, then we set is dead. All right, so the second part of this was the actual blinking. And again, we're going to do this with a lerp. And you can see that this feeds into the actual opacity. So what we're doing is we're getting time, and I've multiplied that by this value here so we can actually tweak how quickly this thing blinks. And I pump that through a sine wave, and again with the lerp. So we have either on, or we can use this sign here. Let's go ahead and start previewing this node. And we should be set to real time, please. Yes. And let's see, we want to change this to 1. There we go. So now we're using that second channel, and you can see we could tune this out if we wanted to. Quick recompile. We make it a lot faster.
Oh.
That's not, how did that look while streaming? Yeah, don't anyone have a stroke, please. Let's go back. Okay, very good. Okay, so again, those are the 2 different components of the material, and we're just basically turning on. Oh, that's worth mentioning actually. Let's jump back here. You can see I'm using the same scalar. I basically just copied that and pasted it down here, and I'm using that to drive the lerp here. So I don't actually have to create 2 parameters. Over here in the graph, I'm just using the one set scalar parameter value. Alrighty, so now what that allows us to do is we can actually add more blueprint functionality here to ramp that up or down if we wanted to. If we wanted to start him out flickering very slowly and then quickly as he returns to his normal state, we could do that. It just allows a lot more flexibility than what we had going on previously with the whole timer-based system. Okay, so trying to think if there's anything else we added. I think everything else is largely the same. So the next thing on the list that I wanted to cover was actually creating a simple weapon system. So if we wanted to swap between different weapons, we could trigger that either with a key press or picking up an item. But before we get into that, that's the actual live section of our show, I'll say. Let's take a look at some of the questions that we have. Oh, here we are. So what would be the most common sense approach to have the player unlock and or upgrade weapons and have a different sprite for each? Okay, so this is similar to what we're talking about. There's a second part of this question, and the user asks, no bone sockets for sprites like they're on a mesh, so do we make the weapon an actor or just add everything into the character? Okay, so yeah, the 2 parts are how do we unlock the weapons, and basically how do we set the sprite for the weapon, and then how do we attach the weapon to the actual character. All right, let's build out the system so we can talk about how we might unlock it, and then maybe towards the end I'll kind of circle back and do the attachment, because there's probably 2 or 3 different ways we want to handle that. All right, so I'm going to save that for a second. Next question, let's say the player has 3 lives. Would destroy actor come every time the player loses a life, or use some teleport trick until the last life is wasted and destroy on game over? Well, you probably don't have to destroy the actor at all. So what we're doing when we die here, because we changed our material, oh yeah, this is great. Let's see, let's fix this up. Default value 0. That's better. All right, so real quickly, let's go ahead and kill our guy. So all we're doing here is we set him to dead. Now, I would probably just add a simple delay at the end, and then I would check an integer for the number of lives that we had. And if that was true, then I would probably just kick back out to some menu that allows you to restart or continue. If you wanted to do a different effect, like maybe the character explodes, I would probably just go ahead and hide the sprite and then add a particle effect for the actual explosion. So there's probably not necessary to destroy the actor at all, really. All right. Okay, we have another question here about the size of the capsule. Okay, so this user was watching the rest of the series, and I found a problem with the size of the capsule. He's created his character from the paper character, as we did. And it seems when he changes the size of the capsule, there's a problem with the collision. It's not touching the ground, but floats. Okay. All right, so this is going to be a little bit difficult to debug specifically, as we don't have access to the project, but we can kind of take a look at this. Actually, front viewport would probably be better for this. So if you remember, oh great, our camera's right in the way. That's awesome. No, I don't want perspective. I want front, but I want lit. I'm just going to temporarily delete this. It's probably a bad idea. All right, so we have our capsule. You can see here we have our sprite and we have our capsule. and I've actually moved the sprite down a little bit. So basically it's just a little bit of fudging. Just, move it around until you get the desired result. It's not going to be necessarily a one-to-one with the size of the capsule to the sprite. This is what ended up working for me. Okay, so let's go ahead and undo that. Oh, yay, our camera's back. All right, so unless there's some other issue there that I'm not getting from the question, hopefully that should get you on the right path. Could we show parallax? I'm going to probably save that for another session. And there was a question about tile maps. Yeah, it's funny. I went back and watched all of the original sessions that we did, and I mentioned tile maps, but I think it was so early and so long ago that tile maps weren't fully implemented. They're more fully featured now, so at some point, yeah, we need to circle back and talk about tile maps. So we'll put that on the list for next time. One-way platforms. Okay, well, we kind of did that a little bit with the ladder. If you remember at the top, we had that plane with the collision set to complex is simple, if I recall correctly, so that we could pass through the side of the plane without any normals on it and then stand on top. So now, since we're doing the trace, real quick, so an example where this is kind of a cool example. If you think back to like Super Mario Brothers 3, there were certain blocks that you could stand on top of. I believe they were the white ones, if I recall correctly. And if you held down for 3 to 5 seconds, Mario would actually like fall back behind him and you could run behind the scenery. So we could actually do something like this. Since we're doing the trace, we could detect whether or not we're on our special platform. And then we'd set a timer. And once that timer expired, then we could go ahead and set our character to falling and then push his Z depth, or I guess that would be his Y depth, to the background. So we could recreate that, or just have our characters drop through, or we could do something where we're detecting we're on a special platform, and if we're tracing down and hitting that type of platform and hit jump, then we could drop through. That's a pretty popular convention in 2D games as well. All right. What else do we have? How do you do pixel perfect package build that has the right aspect ratio? So we kind of covered that in the first, very first session, where we're making sure that our screen resolution is some division of our ultimate intended screen res. So we just defaulted to a 1080, and we're using, I don't even remember, but I think it's like 1/4 that or something. All right. Any multiplayer plans for this series? I had not planned it, but maybe something down the road we could certainly look at. Is there a way to make paper flipbooks work in multiplayer? Okay, this is an extension of the multiplayer. It seems that paper flipbooks never properly update on the client. So yeah, this is not necessarily specific to Paper 2D. This is more of just like a network replication question. So for example, in our case, we have our update animation function. We would just have to make sure that that is being called from the server so that all of the clients get the updated animation. If you go back to our recent GDC presentations, our other tech artist, Osman, did a great session on replication and multiplayer. So some of those exact same techniques would be used here. And finally, how is rendering for pixel art supported in UE4? They're looking for no artifacts or half pixels or non-integer positions, so on and so forth. Yeah, again, back in the very first session, we covered that. So I would suggest you take a look there. All right, so that's everything. Great questions, actually. Those are very good questions. So let's move on to creating our weapon system. We don't want to say that. All right, so currently, as we play, we press our mouse button and we're firing off our projectiles. That's actually a new blueprint called BP Shot. So let's open that up. This is very simple. On the construction script, let's take a look at our viewport first to see what we've got going on. Very simple blueprint. We have a paper flipbook. See here, just a 2-framer animation. And then we've got our projectile movement component, which is just launching this thing at, does that say 200? It's kind of hard to see from here. At 200 units. And so as soon as this fires off, it plays its animation. The material also has a color component. Let's take a look at our shot component, material instance. Yeah, we can see our color parameter there. So what we want to do is we'll set up a system where we'll have 2 or 3 different weapons, and we'll affect, perhaps the color and then how quickly the thing is going to move. And then we could probably, we'll add some parameters to vary the type of movement that we're going to have as well. So we'll probably want to name our weapons. So this sounds like we're going to need some sort of struct. So let's go to our blueprints folder here, and I'm going to right click and I believe we're under miscellaneous. Let's see, miscellaneous or blueprints? Actually, blueprints structure. All right, so this will be our, we'll call this our weapon struct. All right, so we'll open that up. We'll start adding some of those variables that we just talked about. So maybe we'll start with the actual name. And we'll say that's a string. And we'll need a color so that we can distinguish our shots. What else? We'll take our x velocity. That's going to be a float. And we'll also vary our z velocity so that if we want to have these, have more like a wave pattern or something, we can do that. So we'll say wave z. That's probably good for now. So let's set up some defaults here. So I'll just call this the pea shooter. And basic color will be, since this is our pea shooter, should probably be green. And we'll just use that 200 for the x velocity, and then velocity z will be 0. So we're going to go ahead and save our struct, and then I'll close that down. All right, so back on our guy, get our event graph, and we'll want to initialize our weapon at the very beginning. So up here, you see I have this purple box for begin play. Let's make a new custom event, and we'll call it init weapon. So we'll say custom event. That's going to be init weapon. And what we're going to want to do is go ahead and set all of those parameters. So we need to get our struct. This is going to be our weapon struct. We can just call it the same thing. It's going to be of the struct type. Where it is. Let's go ahead and compile that. All right, so we can see all of our parameters there. Let's take this. Set that. I'm going to go ahead and split this. Okay, so next things here. So we're going to want to set up a data table that allows us to customize all of these different things. Let's go back, and is this one? Let's see, data table. And we're going to pick the struct that we just made, our weapon struct. So now the data table automatically knows to create fields for those different settings that we had. So we'll just do like 3 weapons, I think. So we're going to add a new row. And this will be our pea shooter. It's going to automatically pick up those defaults. That's fine. Let's create another new row. So this is new row 0. I'm going to name these things like so. This row 0. And maybe this will be our spreader gun. Make that sort of kind of reddish color, I think. And it came out sort of pink. That's fine. And maybe this one moves pretty slow, so that's going to be like half speed. And the vertical velocity. So let's vary this. Actually, I'm going to go back to our struct. I'm going to add a couple of different things here. Let's add another variable, and we'll call this velocity z range, maybe. And we'll make that a float. Okay, now we can see that because our struct is tied to our data table, it automatically picked that up. So the z range, let's give that a value of 10. So the idea here is that when you shoot, that's actually the wrong row. We don't want that at all. Spreader gun. There we go. So when we shoot and we're on the spreader gun, we'll get a nice pink projectile, and it'll move at 100 units, and it's also going to have, we're going to pick a random vertical velocity of plus or minus 10 units. So that should give us a nice sort of wave effect as we spawn multiple of these things. And we'll make another new row for our laser. We'll make a laser. So 2. So sort of yellow. It's going to be really fast. Right. Actually, I want one more parameter. And this is going to be scale. Now, I'm just doing this to illustrate the point, but normally, if I wanted to have a different shaped projectile, then I would probably just go ahead and author new art. But for this purpose, I'm just going to use the exact same flipbook, and I'm just going to scale it. It's not going to be pixel perfect, but it'll kind of show you the power of data tables and what you could do with them. So let's make flipbook as well. And we'll set that to the flipbook type. Default that to our shot, I believe we called it. There we go. Okay, so if we wanted to set a new flipbook for our sprite, we could go ahead and do that. Go back to our data table, make sure everything's cool. All right, so pea shooter, we have our different colors, our velocities, our scale. We need to set our default scale. Just 1. Our spreader gun, we'll make our scale 2.5. Our laser, we'll make it 0.5. Right. Okay, so next thing, we need to know which weapon we're actually holding at which time. So we'll go back to our character, and we'll need a new variable here. And I'm just going to call that weapon index. And that is going to be an int. And we'll need to figure out which weapon we are at. Well, first of all, we need to figure out how many weapons we have and then which one we're looking at. So we're going to go ahead and get a reference to that data table that we just created. And we want to get the data table row names. So we'll go ahead and we'll pick our data table. Let's kill this for a second. We'll use him later. So we'll go ahead and wire in. And so what this is doing is it's taking a look at our weapon data table, and it's counting how many rows that we have. It's actually reading the number of rows that we have. And it's going to put those into an array of out row names. So we'll go ahead and promote that to a variable, and we'll call that our weapon array. And then from there, we can go ahead and get the number of items in the array, and we'll promote this to a variable. We'll call that the number of weapons. All right, so we know how many weapons we have. We know the names of the rows that they're in. Very good. Now, let's see, what do we want to do next? That's our init weapons. So now we'll actually want to cycle up and down through the number of weapons. And I think I already created actions for this. Let's go to our project settings. I'll take a look at our inputs. And yes, you can see here I've already added cycle weapon up and cycle weapon down. And I'm basically using the bracket keys and or the mouse wheel up and down so we can just kind of roll through them. So we'll use that. Let's start with cycle weapon up. So when we cycle a weapon, what do we want to do? We want to get the actual weapon index that we're currently on. And we want to take a look at our data table again. Let's see, get data table row. So there's our reference to there. And since we named our rows using numerically, we can go ahead and we can just do this. Or no, we should have been able to do that. Well, we'll get our array. We'll do it this way. This is fine. Get. Okay, there we go. This is starting to better. So we'll want to increment this. And then we'll also want to set that weapon index again. Right? But of course, what's going to happen now is if we keep rolling up, we're going to scroll past the number of items that we have in our list. We currently only have 3. So we're going to want to clamp this. And 0 will be the min, and then we'll want to get the number of weapons for the max. Okay, so now we should always stay within range no matter how many different weapons we have in the list. Okay, let's reorganize some more stuff. All right, so we're going to get the weapon index, get that index in the array. Now, if we go ahead and split this struct, you can see all of the variables. So basically, every time we're changing the rows here, fire this up, we're going to update these variables with the new information. So we need to know on our character, go ahead and this gets a little bit tedious, but this is going to be our weapon name. This is going to be our, whoops, that wasn't cool. Variable, weapon color. Again, there may be a better way of doing this, but this is just what kind of worked for me as I was hammering this together. So this will be the weapon velocity X. Weapon velocity Z. Weapon velocity range. Weapon scale. Technically, these are all the properties of the shot. We're going to be modifying the shot. And then we'll call this the weapon flipbook. All right. So we'll go ahead and just start wiring all this stuff together. All right, great. So let's see, that should cover our cycling up through the weapons. We'll do the bottom, cycling back down in a second. Let's take a look here. And this is where we're actually spawning our shot. So we shoot, we're actually spawning here, and this is where we're going to go ahead and update our weapon parameters. But I need a little more real estate for them. Ultimately, I'll collapse this all down so it's not a big ugly mess, but pull that over there. Okay, so when we spawn our shot, we're going to go ahead and let's get a reference to that actual projectile. And we want the, let's start with the actual, we'll start with the sprite flipbook. Let's see here, let's get the actual sprite itself. And can we set a vector parameter, actually? I think I need an intermediate reference to the sprite flipbook. Let's see if I can set this. Oh, maybe not. And if we go back to our material, I think it's probably just called color. Shot material, what do we call it? Color, yes. And let's get our weapon color that we set via our data table. Plug that right in. I moved it on. Okay, so I think that's probably good enough. Shoot, oh, it's black. That's awesome. Turning black. Setting up our sprite material. Created the dynamic instance, so something's not getting set properly. Let's take a look back at our data table. Our weapon data table. Got our second row here. So that's our color. Tell you what I'm going to do. Switching over to the other monitor for a moment. I'm going to load up the finished one and we can kind of see how this all looks because we're running a little bit low on time. All right, so let's go into our character. There's a couple extra pieces in here. So we've got our weapon in it. Oh, is that why? Because I didn't turn on the weapon in it. Didn't put that in our sequence, did I? Yes. So, okay, so we did all this great stuff here, getting all the data table goodness, and then I did not call it on initialize. Get weapon. All right, let's see if that works. Now it still looks, okay, there we go. So there's our pea shooter. We changed the actual color, and that's our laser color. All right, so we could go back through and hook up all the other portions of this, setting the scale, setting the velocity, but we'll go ahead and just jump to the finished product, which could be here. All right. There's our weapon in it. I move things around a little bit. We're cycling up. Here's our clamping of the values. There's our weapon array where we get it. We're actually setting this to the current weapon. Okay, so then we feed in here. So you can see here, I've basically got these two branches. This is cycling up, and then this one I've just selected is cycling down. And then we're just going through the chain here of updating the current weapon with all of the different parameters. So I've got a few extra ones here. You can see that I've also changed the weapon damage. Let's take a look at those. So we've got our pea shooter. Actually, I've colored this one white. This is the flipbook that we're using, the velocities. And then this does 5 points of damage, where our spreader gun actually does 3 points of damage. And our laser, I think, does even more than that. Let's pull down. Where's it? Weapon damage over. Okay, that's only doing 1. Probably because it's faster. So now let's take a look and see what this looks like. There's our pea shooter. I'm going to cycle up. All right, so now this is our spreader gun. And you can see the very cheesy scale effect we did there. Again, if I was going to do this for reals, I'd probably author a nice looking sprite that was larger. And we'll take a look at our laser. And then we can scroll back down like so. Okay, so that was kind of the cooking show version of all that. Jump right to the end. And then, oh, I'm actually printing the weapon string. You should have seen that up in the corner there. There you go. So you can see I'm on the spreader, I'm on the laser. So I could tie this into the UMG, you know, into our player HUD so that we could actually see which weapon. We could display the weapon, an actual icon for the weapon or something if we wanted to. All right, so with the last few minutes, I want to jump back to that first question because that was pretty interesting. It was, so hopefully I've showed you how you can set up the weapon system and cycle through the different weapons, but the other component of this was, now in the design of the character that we have, our character just reaches out and fires a shot. But it sounded like the user who asked the first question actually wanted to attach a weapon to the character's hands. There we go, there. Yeah, that's it. So, a few different ways to handle this. Now, we've got a very traditional retro sprite type of situation here. If you were doing a more, I'll say, modern type of sprite system where you have like a skeletal mesh with you know, sprites attached to it, then yeah, it becomes very simple just to have another sprite component that gets attached to the bone of your sprite skeleton. We don't necessarily have that here because, again, we're more old school. But we can kind of get the same effect. So let's go and take a look at some of our sprites. Let's take a look at our character sprite here. This is our shooting sprite. I'm just going to double click and open that up. And we'll maximize this and zoom in. And we'll show our grid so we can be pixel perfect as always. Now if we go over to the side here, you see that we do actually have sockets. So I'm going to add a socket and I'm just going to copy this for later. That's the name of the socket. We could call it whatever we wanted. We can see the socket shows up. Let's move that over here somewhere. Okay. Now, if you wanted to attach this, if you wanted to have the weapon attached to the character's hand at all time while he's running, I would just go ahead and I would open up those sprites for the running frames and add the same socket. But interest of time, we're just going to do it on the actual shooting one. So I'll save that. Now back over on our guy, let's take a look at our shooting stuff, which is all down here. All right. So after we've updated the animation, what do we need? We actually need another sprite component for the actual weapon itself. So let's look for a sprite. And this could be a flipbook, it could be just, you know, a simple sprite. We'll just do a single framer. Oh, did that add the right thing? No. There we go, okay. So we've got our new, that's not what we want at all. Bear with me, it's a little bit difficult to see from this distance. So we actually want a sprite. Oh, okay, that was, I guess that's what we do want. Okay, great. Sprite. All right, we're going to change this. We'll pick a new sprite. And we have a whole bunch of doodads down here. Let's use this crazy looking wand thing. We zoom in, let's take a look. Okay, so we can see there's our sprite. That's going to serve as our weapon for now. Now, I'm not going to do this super clean and go through all the trouble of hiding this thing and unhiding it, but I'll show you just how to attach it, and I'll let you take it on from there. So we've got our sprite, and I will sort of push that back a little bit, just so we don't have to look there. He'll be hidden kind of behind the character. We'll probably see it when he flips around, but whatever. All right, so back on our event graph, let's go ahead and get this sprite. So again, this is in the shooting component, the shooting part of the graph here. So we shoot, everything's cool, animation is updated, and let's go ahead and set the transform. Well, first we'll want the actual, let's go to our character sprite here. We need the location of that sprite, so of that socket that we created. So we'll get our original character sprite, and we'll get the socket transform, and the name of that was socket 0. And then we'll want to set the actual transform of this. So I'm using a transform instead of location so that if you did want to actually rotate it, you could manipulate the actual the rotation value in here. But again, for our quick and dirty example, we'll just do this. Not set socket, but we want to set the transform on this. That will transform. So as that animation is updated, that should jump that to the right spot. Now again, it's not going to hide itself or be like super clean. Yeah, so as I expected, as we change directions, you can see it. But so now as we fire, you can see that it's actually attached to his hand, his awesome looking magic wand. So again, we could go back to our data table now, and we could say that when we switch weapons, we could also create a new variable for the actual weapon that we're holding. So, you know, perhaps the spreader gun actually looks cool. We could go ahead and set that sprite there. All right, so that was actually pretty fun. That was a cool one to bang together. Alrighty, and any other questions? Oh, let's see. How do you make jumps that go higher the longer you hold down the jump button? So, I would how we're doing jumps right now. Just let's take a look at jumping right here. My comments are. So we're using the jump functionality of the character movement component, and I'm not sure if that actually has functionality built in to do variable length height jumps. So maybe what I do there is I might actually implement a custom jump where I'm applying a force, and it might be a consistent force so that as I'm holding it down, a trigger or a timer is triggered that applies force until you actually let go, and then the character should drop. And then of course, once it reaches the maximum height that you want to allow, you again would just cancel that trigger or that timer and turn it off. That's just off the top of my head. Maybe there's a better way. Ever going to show off something a little more complex like a ledge grab and climbing? Hey, that's a good one. I hadn't considered that, but what I might, the approach that I might do there is I might even just have like simple helper objects in my world that, much like the collision box that we had in our window, or our ladder, excuse me, that set the climbable state to true on our character. I might just have actors in the world that we would place on corners and ledges, and once the character overlap those, I would create a new state for the character called grapple or something, or amble or whatever, and we'd play a new animation and just move the character to the top of the ledge. So very similar to the ladder. You could probably take that ladder and duplicate it and change the behavior there to get that whole ledge grabbing action. Can you have those lasers face their direction? I'm not sure what we're asking there. Let's go to laser mode. Can you have them face their direction? Not sure what we're asking there. All right. Can't you just attach the gun to the player and set the parent socket? And you give the sprite a socket. So I did it at the, so yes. I'm assuming that this question was asked before we actually went and did all of this. So as you saw, yes, I created a socket on the sprite and attached it there. And you have the, okay, so we're getting an update on the laser question. Oh, okay, on the spread shot, they only face left, right, no angles. Oh, I see, I see. Okay, so the question there is, as we go to our spreader gun, so they face, technically, they are facing the direction they're going on X, but could we rotate them to follow their actual direction of travel? Yeah, absolutely. So down here in our shooting system, let's see. Actually, we could probably, there might even be like a super simple way to do this. So we don't even actually have to do any math. Let's take a look at our projectile movement. This might be built in already. Rotation follows velocity. Let's try that. That sounds pretty promising. Spreader gun. There we go. All right, magical. Cool. All right, so that's it for the questions that I see on my list over here, and that takes us just about to the hour. So, all right, our project has been living for quite some time now, and it's actually not in too bad of a shape. So I think what I would like to do is take this and get it into a nice, we'll get rid of our crazy little wand there and clean up a couple other things. And I'll make this available for everyone to go ahead and download so that as we do more of these, we're more up to date and everyone's on the same page. One final thing I guess I'll say. So recently we had GDC, and I just want to say thank you very much to everyone that came up and expressed their appreciation for the Paper 2D series. That means a lot, and it was really cool to see people walk up with their phones and show their side scrollers actually there on device live on the show floor. So thank you very much for that. That inspires me to keep doing these things and making me want to go ahead and actually create a real side scroller myself. So I think that's going to be it for now. Oh, wait, real quick, final question. Do you have motion blur on? I believe I do not. And if we take a look here, this is our post-process volume. And it is set to unbound. And if we take a look at our settings, and we'll look for motion blur. Actually, let's turn that all the way to 0. All right, so hopefully that'll turn it off. Yeah, that should have been off. Cool. Okay, finally, there we go. I'll call that it for today. Thank you very much, and we'll see you on the next one.